Now the moment that you guys will all be waiting for. What is that interaction means, right? We have that interaction all over the place, and he didn't explain what that means. So let's take a look at this example. We have a sample being significant, right? A p-value lower than 0.17. We know that this makes sample being significant. Column being significant as well, less than 0.17. And interaction being significant as well. So all of them are significant, right? And we know that if the two of them are significant, you have something like this. You have the lines separate from each other because there's something going on. They're different. And you have here not a horizontal, right? Some angle going on where they go up. All of them following the same pattern, right? So all of them are following the same pattern here. And that's the interesting part. Now we have the interaction going on. So interaction means that something happened that doesn't follow all the rules, right? So we have some overall rules saying, okay, product one, in this case, we have, oh, sorry, we have product one going higher, lower, we have this, but when we have the interaction, something crazy and wacky is going on, right? So you cannot say that in this case, we put the means here. We cannot say that product one is always have more defects than product two. We cannot say that product shift one is always the best one. So whenever we can't say that this rule will repeat exactly the same way, we have the interaction going on. So which one is the best product? Which one is the best shift? Don't know. What I know that probably, I know the worst shift. Which one is the worst shift? Well, probably shift number three, right? I kind of know which one is the best. I don't know because this is the best in product one, this is the best in product two. So every question has a kind of a different answer there depending on. So that's what the interaction means. The interaction, it kind of highlights some special combinations that are happening and they're not linear. They're not all, oh, this is always the best. This is shift one is always less. Product one is always less. No, we don't have that. We have weird things going on and showing that these two are interacting. The combination of shift and product will dictate which one is the best option. Okay? And for this one, if we do a box plot, we learned how to do a box plots, for example. We can compare the means here, right? So remember that these are means. It doesn't mean that this mean and this mean are statistically different. It doesn't mean that this and this are statistically different or this and this are statistically different, right? To do that, I need to do the two sample t-test. The same thing for all the ones we did, right? For example, the ones that show, of course, the ones that show one and two are different than each other. I only have two categories. They're different. I know what's going on. I don't need to do another test. But for example, the one that we have three shifts, I don't know which one is different. Is one different than two? Is two different than three? Is one different than three? So I have to follow a two sample t-test or do the confidence intervals to see which one is different, which one is higher, which one is not, right? And here the box plot is helping me do that, right? So I do the box plot, I can see that they overlap here, the quartiles. So these two are probably the lowest one. So these guys, product one, you have product and shift, right? PNS. Product one and shift one are the best people to look at when I want to know what is the best way to produce this product with less defect. If I want to take a look at how to produce, but shift one is not, where am I? Not very good. Shift one is not very good in product, shift one is not very good in product two, right? Which is the purple one. But shift two is very good in product two. So I can take a look and see which ones are best to teach the other ones to rework and redo our standard work procedures if we have standard work procedures, to train the others to do the same. Um, so how to do this with Excel. So we have here Excel. It's the step-by-step of how to do that. You go to Data, select Analysis, scroll to Anova two-factor with replication. Okay, so two-factor with replication. Click OK. And then you select the data. It's important that the data is in this format here, which have the columns and have the samples like this. And you have to say how many rows per sample. So it doesn't identify that you're kind of moving things here and kind of dividing here in the middle. You have to say, okay, I have 10 rows here and 10 rows here. You have to have the same size data. And then you put the range and that's it. Just select rows, what is the alpha that you're going to use the significance level. Okay? And it doesn't have the threshold, so you can use whatever alpha value you want. So this is the example for the first one. That's how it presents to you. It does the sum, the average here. So these are the averages that we were using before for shift. These are the average that we're using before for product one, for product two. So we have here the average for product one, here the average for product two. Here's the total averages per group. And here's all the magic with the p-values that we need to look at. In this case, is anything significant? Nope, nothing significant. Nothing is lower than our p-value. What I want you guys to do now is to take a look at that two-way ANOVA problem that you have on Excel and do that for me. So remember, we looked at the four rules were FIFO, LIFO, shortest processing time, and longer processing time. And now we're going to add another variable, right? Because the two-way ANOVA is two variables at the same time. So we had one variable that have four classifications. Now we're going to have a second variable to be high or low utilization. Okay, so we have those two things at the same time. Does utilization affect waiting time? Does scheduling affect waiting time? Do we have any rule should company use for high and low utilization periods? What should they do? What is the practical implication of that? So here it is, the practice, the two-way ANOVA problem, right? You have low and high utilization. We have FIFO, LIFO, SPT, LPT, and you can put the average here and build a chart to help you answer those questions. Okay, and that's what we have for two-way ANOVA. Then